Good morning students. In this video we are going to learn Unit 1 Laws of Motion. Learning objectives, understand the concept of force and motion, know about inertia and its types, understand the definition for linear momentum. When a body is at rest, starts moving, a question that arises in our mind: what causes the body to move? Similarly, when a moving object comes to rest, you would like to know what brings it to rest. If a moving object speeds up or slows down or changes its direction, what speeds up or slows down the body? What changes the direction of motion? One answer for all the above question is force. In a common man's understanding of motion, a body needs a push or pull to move or bring to rest or change its velocity. See this diagram. A body needs push or pull. So, in general, force is push or pull. So, push or pull is called as a force. Now, let us define force in a more scientific manner using the three laws proposed by Sir Isaac Newton. These laws help you to understand the motion of a body and also predict the future course of its motion if you know the forces acting on it. Mechanics. What is called mechanics? It is the branch of physics that deals with the effect of force on bodies. It is divided into two branches, namely statics and dynamics. So, mechanics is the branch of physics that deals with the effect of force on bodies. If the effects take place on their body, we have to say it is called as a mechanics. Now, these mechanics are divided into two branches. One is statics and another one is dynamics. Now, what is called statics? It deals with the bodies which are at rest under the action of forces. So, it deals with the bodies which are at rest. An object continue to be in a same state of position. That is, an object is in a rest position under the action of force is called statics. When we apply a force, an object doesn't move. It may be in a same position. That is, it is in a rest position. It is called statics. And what is called dynamics? It is the study of moving bodies under the action of forces. When we apply a force, an object will continue to move. It is called dynamics. So, mechanics is the branch of physics that deals with the effect of force on bodies. When we apply a force on your body, some changes takes place on your body. So, mechanics deals with the effect of force on bodies. This mechanics can be divided into two types. One is statics and another one is dynamics. So, statics means which are at rest under the action of forces, and dynamics, study of moving bodies under the action of forces. Now, dynamics are further divided into kinematics and kinetics. Dynamics is further divided into kinematics and kinetics. What is called kinematics? It deals with the motion of bodies without considering the cause of motion. It deals with the motion of bodies without considering the cause of motion. If an object will move from one place to another place, we cannot consider the reason why an object is moving. What is the reason for the object to move? Without considering the reason of the object to move is called kinematics. We have to consider only the movement of the object. If a ball is moving, you have to consider a moving ball alone. We cannot consider the reason of why the ball is moving. Is called kinematics. And kinetics. What is called kinetics? It deals with the motion of bodies considering the cause of motion. It deals with the motion of bodies considering the cause of motion. If an object is in movement, we have to consider the reason of the object to move. If a ball is in movement, we have to consider the reason why the ball is moving. If somebody pushed the ball, a ball is moving. Likewise, we have to consider the reason of the ball to move from one place to another place is called kinetics. According to Aristotle, a Greek philosopher and scientist, the natural state of earthly bodies is rest. Aristotle considered that a natural state of all the earthly bodies are rest. He stated a moving body naturally comes to rest without any external influence of the force. Such motions are termed as natural motion. So Aristotle stated that a moving body naturally comes to rest without any external influence of the force. Without applying any force, an object comes to rest. Such motion are termed as natural motion. Now this type of motion we have to say force independent. This object does not depend on the force. So force independent. So a moving body naturally comes to rest without any external influence of the force. It is known as natural motion. Then violent motion. What is called violent motion? A force is needed to make the bodies to move from their natural state and behave contrary to their own natural state, called as violent motion. So a force is needed to make the body to move from their natural state. If an object is in a rest position, we have to apply a force to move the object and behave contrary to the own natural state. Behave contrary to their own natural state means if the object is in rest position, when we apply a force, an object will move from one place to another place. So here an object dependent on the force. So it is called as a violent motion. So Aristotle stated there are two types of motion. One is natural motion and another one is a violent motion. When two different mass bodies are dropped from a height, the heavier body falls faster than the lighter one. When we drop here two different mass of a body, one body having 10 kg and another one 5 kg. So when we drop it from a height, which one falls faster? Heavier body falls faster comparing to the lighter one. See this diagram. Here we have two mass of a different bodies. So these two mass of a different bodies falls from a height. Which one falls faster? Heavier body falls faster. After 3 minutes later, the lighter body falls. So Galileo proposed the following concepts about force, motion and inertia of bodies. So let us see what are the concepts of Galileo. The natural state of all earthly bodies is either the state of rest or the state of uniform motion. The earthly bodies are either in the rest position or in the uniform motion. So the first concept of Galileo is the natural state of all earthly bodies is either it is in the state of rest or in the state of uniform motion. So the bodies are in the rest position or in the uniform motion. A body in motion will continue to be in the same state of motion. If an object is in a movement, if an object is in a motion, it will continue to be in the same state as long as no external force is applied. As long as when we cannot apply any force on the object, an object may be in the same position, same motion. So see here. Here the body in motion will continue to be in the same state of motion unless a driver apply a brake. So unless when we apply a force, the object will continue to be in the same state of motion. It is the second statement of Galileo. And then let us see the third one. When a force is applied on bodies, they resist any change in their state. This property of bodies is called inertia. So when we apply a force on body, it resists any change in the state. So then object takes place any change in their state. So it is called as a inertia. When dropped from a height in vacuum, bodies of different size and shape, mass fall at the same rate and reach the ground at the same time. So when we drop two different mass of an object in a vacuum, in empty space, bodies of different size and shape fall at the same rate. See here, lighter object and heavier object fall at the same rate and same time. Inertia. What is called inertia? When you are traveling in a bus or in a car, when a sudden brake is applied, the upper part of your body leans in the forward direction. When we travel in a bus or in a car, when the driver apply a brake, our upper part of our body leans in the forward direction. Similarly, if the vehicle moves forward from rest position, you lean backward. So why it takes place? Why the our upper part of the body lean forward and lean backward? What is the reason? This is due to any body would like to continue to be in its state of rest or the state of motion. An object may continue in the rest position or in the state of motion. This is known as inertia. Now, what is known as inertia? Let us see the definition for inertia. The inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force is known as inertia. The inherent property of a body, the essential property of a body to resist any change in its state of rest or the state of uniform motion unless when we apply an external unbalanced force, it is known as inertia. If an object is in a rest position or in a motion, it will continue in the same state of position unless when we apply an unbalanced force. It is known as inertia. Now let us see an experiment for inertia. Take a glass tumbler and place a cardboard, small cardboard on it. Now keep a coin at the center of the cardboard. Take a glass tumbler and place a small cardboard on a tumbler and keep a coin at the center of the cardboard. Then flick the cardboard quickly. When we flick the cardboard quickly, what happens? The cardboard falls off the ground and the coin falls into the glass tumbler. So this activity shows that the inertia of the coin keeps it in the same state of rest when the cardboard moves. So the inertia of the coin keeps it in the state of rest when the cardboard moves. So the coin is in a rest position. When the cardboard has moved, the coin falls into the tumbler due to gravity. So this happens due to inertia of rest. Now let us see the types of inertia. So there are three types of inertia. One is inertia of rest, inertia of motion and inertia of direction. Now what is called inertia of rest? The resistance of a body to change its state of rest is called inertia of rest. So the resistance of a body to change its state of rest. If a body changes its state of rest, it is known as inertia of rest. So when you vigorously shake the branches of a tree, some of the leaves and fruits are detached and fall down. See this tree. Now the leaves are at a rest position. So when you shake the branches of a tree, what happens? The leaves and fruits are detached and fall down. So this is a inertia of rest. Next one, inertia of motion. What is called inertia of motion? The resistance of a body to change its state of motion is called inertia of motion. So if a body changes its state of motion, it is called inertia of motion. Example, an athlete runs some distance before jumping because they will help him jump longer and higher. So before jumping, an athlete runs some distance. Say this diagram, he runs some distance and then jump. So it is called state of motion. Inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Example, when you make a sharp turn while driving a car, you tend to lean sideways. So when you are driving in a car or a bicycle, so we have to lean sideways. If you have to make a sharp turn, we have to lean sideways. This experience takes place when you are riding in a bicycle also. So it is called inertia of direction. Now let us go to the next topic, linear momentum. What is called linear momentum? The impact of a force is more if the velocity and mass of the body is more. If the velocity and mass of the body is more, then the impact produced on a body is also more. So the velocity and mass of the body is more, the impact of a force is more. So to quantify the impact of a force, we have to use a new term. It is called linear momentum. So to quantify the impact of a force, the force produced on a body, we have to quantify by using a new physical quantity. That physical quantity is called linear momentum. Consider if you have to take a ball, we have to consider the mass of a ball and velocity of the ball. If the mass and velocity of the ball combine together and then it produces some changes, it makes some changes on the object. So we have to quantify the new term as a linear momentum. So this linear momentum measures the impact of a force on a body. This linear momentum measures the impact produced on a body. What are the changes takes place on a body? So now let us define linear momentum. So the product of mass and velocity of a moving body gives the magnitude of linear momentum. If the mass and velocity combine together, then only it produces a linear momentum. So it acts in the direction of velocity of the object. The linear momentum acts only in the direction of the velocity of the object. So this linear momentum having both magnitude and then direction. So it is a vector quantity. So linear momentum is a vector quantity. If we have a less mass of an object and then the velocity also less, then the impact produced on a body also less. So it depends upon the impact depends upon the mass and velocity of an object. So we have to quantify this as a linear momentum. So if the mass and velocity combine together, then only the linear momentum will takes place. Suppose if the mass is greater but the velocity is less, then the linear momentum does not takes place. Okay, so the linear momentum means some changes takes place on the body. So if the impact produced on a body, then we have to say it is a linear momentum. So this linear momentum is a vector quantity. Now what is the formula for linear momentum? Linear momentum equal to mass into velocity. We have to use the letter small p for linear momentum. So P is equal to linear momentum, m is for mass and v is the velocity. So P is equal to mv. It helps to measure the magnitude of a force. This linear momentum used to measure the magnitude of a force. Now what is the unit for linear momentum? So you already know the unit for mass is kilogram and then the unit for velocity is ms minus 1. So the unit for linear momentum is kilogram ms minus 1. And then in CGS system, the unit for linear momentum is gram centimeter s minus 1. For in CGS system, the unit for kilogram is gram and then for meter is centimeter and then for second it is second. In all the systems, the unit for time is second only. So we have to write it as second. So what is the unit of momentum in SI system? Kilogram ms minus 1. What is the unit for linear momentum in CGS system? Gram centimeter s minus 1. So the formula for linear momentum is mass into velocity. This linear momentum is used to measure the magnitude of a force. Magnitude means quantity or amount of a force. We have to, using this linear momentum, we have to find out the value for the force. And the SI unit for linear momentum is kilogram ms minus 1. And then in CGS system, the unit for linear momentum is gram centimeter s minus 1. Thank you, students.